Yesterday's in introduction we said that unless and until I have not got sufficient and enough light which is falling on the object, my camera will not capture accurately and correctly. In our robotic case, mainly our domain is dominated with industrial robotics, where we are performing various robotics tasks on the shop floor, where robots are working on different machine parts. They are performing different processes. They are doing delicate tasks as well as rough, hard tasks also, like cutting or various operations, laser cutting, right? Second part, we require both the type of things: clear view, texture view, very finer view, enlarged view, because that is what our measurement part, that is what our inspection part in these all operations. Generally, whenever we work on shop floor, lot of noise, lot of work is going on. There is electromagnetic noise. There are machines around us. They are emitting. They are making radiations. So sensor noises are obvious over in that environment. Second part is generally we are having light and descent lightning, where humans are working and machine processes are going on. But yesterday we have seen camera is having various types of positions: fixed camera or onboard camera. So whenever we are capturing, at that time sufficient light must be there, and we have got various positions. It is like small technical photo studio, wherein we want to capture image of our interest very accurately, because all of our operations are dependent on that image. Mainly our decisions are dependent on the clarity and accuracy of that image. That's what we said, that when we assign camera to robotic manipulator, it will act as an eye, but this eye must be calibrated correctly. That we have to ensure that whatever view we are capturing, that should be very correct and accurate. Now, one of the part of this camera photography is the light or lightning conditions. All of you know we are using all these cameras daily life. So lightning techniques are very important part. But now here case is different. In our cases, maybe objects are unique, objects conditions are kind of similar, or we are not expecting greater accuracies in that day-to-day life problems. Here we are having various kinds of objects. We are having various small micro tasks as well as broader tasks. For example, if I am going for machine inspection and a bot is inspecting a particular machine, wear and tear especially, a particular nut, bolt, thread, any other part through camera. Now, lot of detailing is required for this part to identify which part is damaged. And to get that detailing, again, everywhere the surface texture will be different. The light reflected from that surface is different. That's why every problem becomes unique. And every problem becomes unique case. So we need to adjust whenever we are going for internal parts of machine, or we are going to work in low light, whenever we are going to work in complicated spaces. At that time, each of case is resolved and we ensure that there should be enough light. And all of this gives, along with camera installation, illumination is an important problem here. So light must fall correctly on that object, and that should reflect properly and enter in the camera so as camera can enable the correct image capture, and our region of interest in that image must be highlighted so as we can further process it, take decisions, perceptions from that image, and we can program further operations. Various illumination techniques are there. Many of times illumination techniques are dependent on problem nature also. But some of illumination techniques we are discussing here. The illumination techniques are mainly like structured light, where we are having particular arrangement of light so that a region of interest can be properly highlighted. Front and back lighting depends on transparent or opaque jobs. Beam splitter, whenever we want to divide light correctly. Then retro reflectors, many times we want to calibrate or align correctly the reflections. Specular illumination, diffuse lighting, directional lighting, these are some schemes. They are worked for the actual problem. Now all of us know the process of image capturing, where light is falling on that object and then it will be reflecting. This reflected light is captured by camera. It is falling on the lens, then it goes on sensor, and sensor grabs all of this reflected light and convert it into electronic signal. Now in true life or in real life, we find that the objects are having various properties, or rather surface of the object is having various properties. So whenever total light falling on it, some of light can be absorbed, some of light will be reflected, some light can be transmitted that can go through it, or some light can be emitted. Sometimes fluorescence colors are there, fluorescent color is applied on object, or fluorescence nature of the surface is there, then light is again emitted back also. And all these reflections are captured by camera, and other part, absorption and transmission, this part is generally not in our control. So to get a good image, maximum reflection should occur on the lens of camera so that we can capture better image. Now basic lightning techniques are there. There are two things: camera position and the light source. Mainly lightning techniques or illumination scheme means what? We are arranging, or we are designing patterns how light will fall on object and how maximum light should go back to camera, so that clarity of the image will be there. Only clear image can be used for recognition and further decisions. Otherwise, recognition accuracy will be reduced. Basic lightning techniques are like partial bright field. So slightly we increase brightness so that reflection can be increased and we can get clear view. Whenever simple arrangements are there, camera is at 90 degrees, and then light source can be inclined, and we can have sufficient light. So very first and basic lightning technique is partial bright field, wherein we adjust brightness on that particular object. Remember, if you anytime visited photo studio, then photograph person or photographer is having his own umbrella, LED lights, so that light on your face is adjusted, and that's why you are getting clear and good photos. Natural light may not be sufficient many times. That's why artificial light is one of the solution in these problems. Now If surface is normal, then partial bright field can work, so it will give clear view. But if surface is shiny, in that case we need to adjust the lightning source at 45 degrees, so as some dark part will be sheer, so shiny part can be captured correctly and there will not be irrelevant reflection. Remember, polished jobs, polished surfaces, polished aluminum, polished steel, and whenever we are dealing with such materials, then there will be huge scattered reflection that can give scattered view in image. So you have to control back that scattering, so as you are adding lightning sources such that some dark field will be created and shiny jobs can be correctly captured. Further, in case of transparency, if you are got transparency, glass, plastic, or many other transparent things are there, then light can pass through object. So light source will be below the object, and you can capture the vision, the area correctly. Some special techniques are there where we need to align light source correctly. So we can use reflectors, we can use other methods of light. So you can go for coaxial diffuse whenever we want light to fall in the direction of the camera. In earlier cases, remember, we are slightly away from the camera and light is falling from different angles. In coaxial diffuse, coaxial, that means axis of the camera and axis of light source both are going correctly. So a reflector or filter is generally placed in front of light source, and that will now reflect light 90 degrees without obstructing camera view, and camera can capture in line with the light source. If processes are very small, micro, surfaces are very small, then we need covered area. So lightning should be having full illumination across the all surface. So diffuse dome is in that case working. So diffuse dome gives light on the all surface, so that wherever that smaller area is there, that will be captured easily. On the contrary, if you are having large or larger area, then you can use flat diffuse. So you can have LED arrays or light source arrays, and whole capturing area is fully illuminated. So as camera can get everywhere equal brightness or full bright fields. Now let us discuss this all methods or some of these methods and how they are used in real life when we are installing camera along with robot. Backlighting is mainly preferred for edge detection or holes detections. Mainly it is useful in translucent materials or liquid filled objects like bottles, or you are having various types of consumer products, glass, plastic, to find cracks. So high accuracy measurements you use in transparent and translucent materials backlighting. Major characteristics is that the source is passing all the light from material, and whatever either level or some text or some other aspects you want to capture from that transparent area, that will be highlighted on the surface correctly. So source is below the object whenever backlighting is there. Example of backlighting is now bottles. So in a consumer product, it is major task to measure or to perform various measurements on filled bottles. Then they might be oils, they might be various types of consumer products. So wherever transparent bottles are there, this backlighting technique is giving good view. Now another thing is that what is color of bottle, and then whatever you want, that must be highlighted correctly. So one has to adjust wavelength of the light. Many times infrared sources can be used to detect levels or cracks and other defects, or specialized wavelength sources can be used so that you can highlight the particular thing. So according to color and material, we will adjust the light and the light source nature. In diffuse lightning, for smooth objects, many times direct light falling on the object may create problem. So diffuse dome or coaxial diffuse or flat diffuse, wherein light sources can be more than one, and you adjust the reflection of the light and it will be coming back to camera and it is ensured. So light is not directly falling, it is coming through diffusion, coming through reflectors or through some other light materials which are surrounded in the light sources. So direct light falling will have problem in smooth objects. They can give scattering. To avoid this scattering, you can have diffuse lightning sources. One example here is, now there are metal cans from soft drink to various paints. Everywhere we use metal cans in our consumer engineering. And all these products are mass manufactured. We need quick identification of the parameters, various parameters. One of the application is like detection of the text on metal can, that is shown on the screen. Now here problem is, metal is having maybe aluminum cast, very shiny surface. If direct light is falling, it will be scattered and camera can see nothing. On the contrary, we need that text exactly in this example. So we go to opposite to the dark effect or dark field. We apply indirect light over here, and then we make sure that whatever our region of interest, that is this text, will be shown very correctly. So this is what we require. So it's shown, it must be shown correctly. See that all surrounding area goes black and only on required area light is falling. So this dome is constructed such a way that it is calibrated reflection light only in the required area. All surrounding area turns black, so that less scattering will be there and only our shiny part will be highlighted correctly. Another example is coaxial diffuse. In this example, glass materials are there. Either you want to measure level, or either you want to inspect various cracks or any other parts. In this case, beam splitter can be used, angle of elevation can be used like discussed in last slide, the camera will be in line with the light source and light straightly fall on the object. And the surrounding area light may not be very efficiently it is covered, only our required area will be highlighted. Remember, this is very difficult in real life. If this view has not got, our operation may not be complete. And such a many objects are there to be inspected in our case. Another example is now checking array. So in this case, there are lot examples are there, right from tablets in pharmaceutical factory, which are palleted together, or you are having array where bottles are there, objects are there, and they are moving towards packing, and large amount of objects are there. So quick detection is required. Very fast decisions are to be taken, whether object present is or absent, and other measurements. So wider view is required. So we enhance diffusion. We have hybrid diffusion, that is coaxial and dome, but dome will be up more sight and more light sources are there, so larger area will be covered. Now here you will find comparison of all this field, where which illumination scheme can be used, that is also discussed. Another thing is structured light. Now sometimes we are interested in very minute details and very small details like surface scratch. In this case, we define particular structure to detect our required parameter. For example, on this particular surface, which is mirror surface or very shiny polished surface, and we cannot afford a single crash over there or small diffusion or small deformation can damage whole process, and they are never allowed in our routine manufacturing. In such cases, now special arrangement is done for structured lightning source, so wherein multiple sources can throw light, create darks and opaque zones, and region of interest is carefully highlighted. Even colors are managed or color filters are applied, and only required area will be shown. Now here we apply different light sources. Whenever final image comes to us, there will be combination of filtering of the colors, and only this whiter scratch will be passing. Rest all contents are dumped. This is what structuring what we are talking. Ideally, in real life or in manufacturing or in industry, this needs lot of experimentation. Several times building software or constructing robot is one part. This takes a lot of efforts because these are very delicate and smaller tasks.